Hello, so if you could turn to page 41 in your packet, today we're going to talk about parabolas. All right, so if you look at the top of your paper here, it says a parabola is the set of all points in the plane that are equidistant, which just means an equal distance from focus F, which is a point, and directrix L, which is a line. Okay, so let me draw this out for you and show you what this means. So let's say we have a point and put it right here. Okay, this is called our focus. And then let's say we have a line. Okay, we're going to call it D for directrix. Now, the parabola is the set of all points that are equidistant or an equal distance from this point and this line. So if you were to work your way in the middle, right, if I were to come down here and up here, we'd have a point somewhere right here in the middle. Okay, I'm going to make it red. Okay, that right there, that's called the vertex of our parabola. Now, let's say I went out in this direction and I went up, right? What I'd notice is there's a point right here, somewhere about here, that's an equal distance from, well, that looks a little closer to the focus, but that's the same distance from the focus and the directrix. Now, let's say I went in this direction. Figure somewhere out here, there'd be a point that's an equal distance from the focus and at the same time an equal distance, that's an equal distance from the directrix. Okay, what's going to happen is as you keep making these points, they're going to form what we know to be a parabola, just like that. Or if we look at the drawing on our paper, right, this is a better picture, okay? Here's your parabola. Okay, now if you look on the bottom of the page, this is the format for the equation of a parabola that opens up. Okay, so a parabola that opens up looks like this. It's like a smiley face. And this down here is the format for the equation of a parabola that opens down, okay, like a sad face. And if you notice, the only difference in the formulas is that this one has a negative in front of it, okay, meaning it opens down, whereas this one has a positive. We don't actually put it there, but it has a positive in front of it, meaning it opens up. All right, now whenever you go to write these equations, you leave the x and the y, okay? You leave them in terms of x and y. But see this p right here and this h and this k? We are going to replace those three with numbers. Okay, so let's start with where the p comes from. The p, we can see right down here, it's the distance between the vertex and the focus. Okay, so here's your vertex and here's your focus. It's just the distance between these. Or it's also, look down here, it's also the distance between the vertex and the directrix. Okay, it's the distance between the vertex and the directrix. Remember, the distance between the parabola and the focus is the same as the distance between the parabola and the directrix. So P will be the distance from either one of these. Okay, the H and the K. See right here it says the vertex gives us the H and the K. Basically, the H and the K comes from the coordinates of the vertex right here. So you plug the X value of that vertex in for H and the Y value of that vertex in for K. All right, so let's take a look at the next page and let's apply these formulas to some examples. All right, so number 86, it gives us a graph right here. So if you want to use the graph to help you out, you can. Some people like to, some people don't. I'm going to use the graph here. So it says write the equation of a parabola with a focus of 3, 7 and a directrix of y equals -1. All right, so let's graph these. So if we have a focus at 3, 7, I'm going to go over 3 and up 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to put a point right there. Okay, so that is, I'm going to label it F for focus. Okay, now we have a directrix of y equals -1. Now remember, y equals has to cross through this y-axis. So y equals is always going to go this way. It's always going to be a horizontal line. So if we have y equals -1, we're going to go down to -1 and draw a horizontal line. Okay, so that is our directrix. You can put a D for directrix if you want. All right, now let's think about it. A parabola is the set of points that's an equal distance from a focus and a directrix. So let's see how far apart these are from each other. You could count, right? You could say, all right, if I start down here, it's 1, 2, 3, 4, 5, 6, 7, 8 units apart. So if these are 8 units apart, wouldn't half of 8 be 4? So you could either go up 4 units from here, right? 1, 2, 2, 3, 4. Or you can go down 4 units from here. 1, 2, 3, 4. Okay, so that brings us to the coordinate. Let me put that right there. Of 3, 3. Okay, this is our vertex. It's going to be at 3, 3. Right, because we went from the origin. We went over 3 and up 3 to get there. Now, the sketch of your parabola doesn't have to be great. I'm just going to draw a parabola. Now, here's the deal. You have to decide, does my parabola open up or does it open down? Okay, your parabola is always going to open away from the directrix. So see how the directrix is down here? That means our parabola is going to open up like this. Okay, our parabola is going to open up. The parabola kind of like surrounds the focus, right? It puts the focus within it. All right, so now they want us to write an equation. Okay, so here's the format of the equation of a parabola that opens up. Remember, the only difference between opening up and opening down is if it opened down, there'd be a negative here. Okay, so we want to leave this equation in terms of x and y. So I'm going to leave the x and the y in that equation. All right, now, if we look here, it says 1 over 4p. So 1 over 4 times, well, if you remember, isn't p the distance between the focus and the vertex? Or it's also the distance between the vertex and the directrix. So we know that to be 1, 2, 3, 4 units. Okay, same thing here. 1, 2, 3, 4 units. So I'm going to replace that p with a 4. Okay, now the h and the k come from the coordinates of our vertex. So h is 3, and actually k is 3 as well. So they're both 3 in this case. Okay, so here we have a minus sign. So x minus 3. Close that up and square it, and then plus, and we said k was also 3. All right, the only thing I'm going to say to do to make this equation a little prettier is let's multiply together the 4 times 4. So y is going to be equal to 1 over 16 times x minus 3 squared plus 3. And there you have it. That is the equation of the given parabola. And if you do want to check in your calculator, I just typed this equation into y equals the one we got. And if you hit graph, okay, you could see, I mean, our parabola, I mean, on the calculator, it looks a little wider. But if I come over here to 1, 2, 3, 1, 2, 3, right, we can see our vertex is at 3, 3, just like we have over here. And it's opening up. Okay, so you could use your calculator to check graphically if you'd like. All right, let's take a look at 87. All right, so determine the equation for a parabola with the focus at 4, negative 1. All right, so this time let's go to 4, 1, 2, 3, 4, and negative 1. Okay, so that's going to be our, let me make that a little thicker. Okay, that's going to be our focus. And the directrix is at y equals negative 5. So we're going to go down to negative 5, 1, 2, 3, 4, 5. And we're going to draw a horizontal line there. Okay, that one's pretty thick, sorry. So that's our directrix. Okay, so now if we want to make our parabola, we know the parabola is equidistant, or an equal distance from this focus and this directrix. So if we count from here, right, these are 1, 2, 3, 4 units apart. So what's half of 4? 2, right? So if we go from the directrix, that very thick line that I have there, and go up 1, 2 units, or if I had gone down 2 units from the focus, right, 1, 2, it would wind up right there. It looks like the coordinates of that would be 4, negative 3. Okay, so that's our vertex at 4, negative 3. All right, now let's think about which way our parabola opens. The parabola always opens away from the directrix. So look, away from the directrix is going to be opening up again. Okay, it kind of engulfs that focus. So it's going to open up again. Although I think that the parabola would look actually a little wider than that. All right, so let's think about the equation of our parabola. All right, so we know we're going to leave the y and the x within the equation. And p is the distance from the focus to the vertex, which is 1, 2 units, or the distance from the directrix to the vertex, which is also 2 units. So I'm going to replace this p with a 2. So this would be 1 over 4 times 2. I mean, if you want to just jump right into writing 1 over 8, that's fine. All right, now, in place of the h, we're plugging in the x-coordinate, which is a 4. So x minus 4 squared. And then plus, well, the y-coordinate is a negative 3. So plus negative 3. But instead of writing plus negative, isn't a positive times a negative just a negative? So I'm just going to write minus 3. All right, so let me rewrite that as y equals, instead of 1 over 4 times 2, we could write 1 over 8, and then times x minus 4 squared minus 3. And there we have it. And if you want to, graph that in your calculator and just check that it looks something like this. I mean, it'll look a little wider than that, then you can. Okay, so now I'm going to have you flip ahead. I think it's page 45 to number 92. So this time, look at this. This time they give us the equation of the parabola. And if you notice, look at that. There's a negative, which means our parabola is going to open down. So we're going to have a parabola that looks like this. It opens down. Okay, so if it opens down, remember, if this is our vertex, it opens away from the directrix. That means this time our directrix is going to be on top of the parabola, and the focus will be below the parabola. All right, now I'm just looking ahead. It tells us here that the focus is at 3, 1. So I'm going to go over 3 and up 1 and put a point. Okay, that's where our focus is. So at 3, 1, we have a point. Okay, there's our focus. Now, let's look at the equation of this parabola, okay? We know that we get our h and our k from these two values right here. Now, let's think about this. Doesn't it go x minus h and then squared plus k? So this 3 has to be our h, and this 6 has to be our k. So the coordinates of our vertex, I'm going to put it right here, are 3, 6. Right, I'm going to go do that on the graph. So I'm going to go over 3 and up to 6, and I'm going to put a point. Okay, so I'm putting a point right there at 3, 6. Okay, that's going to be our vertex. I'll put a V in front of that. All right, now, we know a parabola, right? This negative tells us our parabola opens down, so it's going to open this way. Okay, now what the question wants us to find is, it says determine and state the equation of the directrix. Okay, so since our parabola is opening down, right, we know the directrix, look at this, it's going to be above the parabola. It's going to be somewhere up over here. So we have to figure out exactly where that's going to be. Now, there's two ways you could do it. If you want to do it by looking at the equation, remember the denominator of this equation, see this 20? Don't we know this is equal to 1 over 4p? I mean, it's negative because it's opening down. But the denominator is equal to 4p. So think in your mind, 4 times what gives you 20? Doesn't 4 times 5 give you 20? So p must be equal to 5. Or you could have just counted, right, from here. If I count, the distance from the focus to the vertex, it's 1, 2, 3, 4, 5. So what that means is we would have to go up 1, 2, 3, 4. Ooh, I'm off the graph a little. 5, right, at 11. Let me just kind of draw a line there. Okay, our directrix is going to be up here at a height of 11. I mean, if you think about it, see how the y-coordinate is 6? If you add 5 units to 6 units, wouldn't that bring you up to a height of 11? So the equation of this line would be y equals 11. Okay, and finally, the last one we're going to take a look at today is on the bottom of this page. It says, which equation represents a parabola with a focus of 0, -1? So let's graph that. We have a focus at 0, -1. So it means we go over 0 and down 1. So that is our focus. And a directrix of y equals +1. Okay, so we're going to go to +1, and we're going to graph a line at y equals 1. So those are pretty close together, right? All right, so we know a parabola has to be in the middle of these. So directly in the middle is, look, right there at the origin. So right there, there's our vertex. So So the coordinates of that point would be 0, 0. So our h and our k are both going to be 0. All right, now this parabola, right? If the directrix is on top, it means the parabola has to open down. It always opens away from the directrix. So a parabola is going to open down. So if it opens down, we know that we're going to have a negative in front of our formula. All right, so we know we leave this in terms of y. Might as well put the negative there, right? And x. All right, and let's plug in our numbers. So it's going to be 1 over 4 times p. Well, p, look at that. The distance from the focus to the vertex is 1. Or the distance from the directrix to the vertex is 1. So p is just going to be 1. So if you want to write 4 times 1, you can. I'm just going to make that a 4. Okay, then we know, actually I'll show the work here. We'll make that a 1. Then we know that our h and our k are both zeros. So this is going to be replaced with a 0 as well as this. All right, so that leaves us with y equals negative 1 over 4. Now x minus 0 is just x, so this is going to be x squared. You no longer need the parentheses. Oop, this was supposed to be a 0. Look at me, I forgot to replace it with a 0. And then plus 0 means we don't have to write it. So this is the equation of our parabola. Although I'm looking, look at this, I don't see that there. Ooh, but what do you notice? Look at every answer choice. Don't they all have the x squared by itself? So we want to get this x squared by itself in our equation so that it looks like one of the answer choices. Well, if you want to get rid of a fraction within an equation, don't we just multiply by the reciprocal? So I'm going to multiply both sides of the equation by the reciprocal of negative 1/4, which would be negative 4 over 1. And the reason I do that, let me do that over here too. Sorry, that negative's kind of coming off the screen. That is a negative there. Let me see if I can get that on there better. Negative. Okay. The reason I do that is because the negative 1/4 cancels with the negative 4 over 1, leaving me with x squared. And then when I distribute, negative 4 times y would be negative 4y, which leaves us with choice 2.